All right, let's do some math here. We're going to start off by reviewing some material from previous week that everybody's gone through just to get us warmed up to this brand new online environment. So we have a function of two variables. Let's suppose f of xy was x squared minus y plus 3. This would graph into some sort of a three-dimensional shape that we don't necessarily know what it looks like. We have this direction that we're going to sketch the level curve at the point on the graph that we're going to get in a moment when z is 1. Remember the level curve? The concept is where it's like getting off at the first floor of this strange three-dimensional building. We're going to see what the graph looks like. So we take x squared minus y plus 3 and set it equal to 1. And with a little razzle-dazzle, we will get y equals x squared plus 2. A graph we should be pretty familiar with. So this parabola opens up and its vertex is 2 units up on the y-axis. On a graph paper, this would look much better. On the whiteboard, it probably wouldn't look much better. So we have this two-dimensional graph. So this parabola is called our level curve. Now, that's from the beginning of the chapter. If we take the function f and we find its gradient, the gradient of the function, we get a vector that's made of its x partial derivative and its y partial derivative. And that would be, let's see, not very fancy here. The partial x derivative is 2x. The partial y derivative is -1. You should slow down and check that if that doesn't come to you quickly. So we have this thing called gradient. And we're trying to see how these two worlds compare together. So if we were to find a point on this parabola, when x is 2, it turns out that y is 6. And we were to establish what is the gradient when x is 2 and y is 6. X is 2, 2 times 2 is 4. The y component is always -1. So this vector is normal to the level curve at the point 2, 6. And if I were to sketch this on the graph, I would draw a vector that is 4 units to the right, 1 units down. Now, of course, I don't have a good scale here. Now, this is paper, so I'm going to kind of cheat. All right. So that vector goes 4 units to the right, so I guess that would be 6, and 1 unit down, so I guess that would be 5. Direction and magnitude, remember. And if you look in section 13.6, you will see that there are some other properties of the gradient that you will find related to how this relates to the three-dimensional surface. Now, before you go on to the next video, I strongly encourage you to repeat this process for problem 13.6, number 55. And I'm going to attempt to get the solution up there, but it is an odd number, so you can always check on CalcChat or one of the other sources to see what the solution looks like. Good job.